Hello and welcome back to the Flat Earth Science series. I've been off for a while, but now thanks to Sleeping Warrior, he got me back on track with episode 5, Sleeping Warrior versus Buoyancy and Gravity. And if you didn't see my previous episodes, I hope you can check it. It's very simple and it explains a lot of things uh, that's been confusing some people. So back again to Sleeping Warrior versus buoyancy and gravity. And when I talk about gravity here, I'm not talking about the attraction between masses. I'm just interested in the downward acceleration of 9.8 meters per second. And it is a fact that every object, everything we see in this earth is affected by downward acceleration of 9.8 meters per second. If you put something on a slide or on a ramp, you can calculate the speed or the acceleration of this object based on the 9.8 meters square and the inclination angle. The road curves bank or tilting of the road is calculated based on the 9.8 meter per second. Projectiles. The vertical speed of the projectile is always reduced by 9.8 meters per second. And finally, which is my favorite example, and I'm going to go in a deeper look for it, the turns of airplanes, more specifically coordinated level turns, must be coordinated level turns. And coordinated means that the force of the lift of the airplane is vertical on the wing, and level means that the airplane is not losing or gaining altitude, and that means the vertical component of the lift is equal to the weight. So in this example, I draw this triangle of forces, or we can call it the triangle of accelerations. We have the 9.8, and based on this bank angle, we can get the centrifugal acceleration, and then we can get the load factor. So I'll not go deep into the math, but you can put any angle and follow this math, and you can compare it against this site, and I will leave the link in the description. Now, that's about gravity. Now let's go to what Sleeping Warrior is saying. He says that gravity is not important. The only thing that matters, or what define why things go down or up, is relative density. And actually, it's a very neat theory. In this case, I'll presume an object that is less dense than the fluid it's submerged in. And for simplicity, I'm talking about submerged in liquid, not partially submerged. So he says that if the density of the object, PO, is less than the density of the fluid, PF, or rho F, then the object will go up. And we can add something to this. The density of the object multiplied by the volume of the object, if they are less than the density of the fluid multiplied by the displaced volume of the fluid, then again the object will go up. The density multiplied the volume is the mass, and we're still going with Sleeping Warrior theory. This is all good until we go a little bit more scientific and we add the G. And this is the formula for calculating the buoyancy or the buoyant force, and deciding if object is going to rise or go down. So Sleeping Warrior, in his egg experiment, he had a claim that it's only density versus density that decide how objects behave in fluids. So he manipulated the independent variable of the density of the fluid, and it did affected the experiment. But he totally ignored that there could be a possibility of another factor, which is the downward acceleration that I just showed that it's something real. So, how can we manipulate this downward acceleration? And what's going to happen if we manipulated and we made this g to be, for example, 0? If we made the g to be 0, then the mg will be 0 and the pvg will be also 0. So it's a 0 versus 0, so there's no upward, there's no downward. The object will be just suspended or maintaining its position in the liquid. And if it was initially climbing, then it will cease to climb, except for maybe with a little bit of inertia or the fluid dynamics. So let's see some experiments here. This video is from Action Lab, and I'll put the link to it. And we can see he's blowing air in this bottle, and this bottle is suspended, and then he will leave it or drop it. Once the bottle is dropped, you see now the air bubbles are suspended. The air bubbles are less dense than the water, but since the air bubbles and the water are no more subjected to the 9.8 meter per second square, then the rules of which goes up or which goes down doesn't apply anymore. There's also another experiment in a zero-G flight, as we see here. You can see kind of like a tower, density tower, and he had to shake it just to make them kind of mix. And you see the guys in the background just to show that there's no gravity, and they're still mixed. They cannot separate. Now watch when this guy is able to stand. He's still floating here. Now he stands. Within a couple of seconds, you can see that the liquids separate again. So, Sleeping Warrior, if you're interested in science and manipulating the variables, get back to the experiment and try to manipulate something, let's say that it's suspected to be a factor in this experiment. And if you are not good at dropping things or not able to go in a zero-G flight, contact me. I have a better experiment than both of them. Thank you all for watching.